Hi, I am Zahra Shariff.
My name is Lauritz Jarmel Oli.
I'm Access Euron D. Morales.
My name is Fionnah Faye Pomida.
I'm Katrice Rika Oamil.
My name is Laurince Baylen, and today I'm here to talk to you about the Descartes rule of sign. So what is Descartes rule of sign? A Descartes rule of sign is a technique or rule that is used to find the maximum number of positive real zeros of a polynomial function. It is further extended to find the maximum number of negative real zeros as well. Thus, Descartes' rule of sign can be used to find the maximum number of imaginary roots or complex roots as well. Rule of sign determines the relationship between the number of positive or negative real roots and the number of sign changes of a polynomial function. Here, the sign change refers to it's either positive to negative or negative to positive. This rule is not helpful in determining the exact number of positive or negative real roots though.
These are the objectives for our lesson. First, we need to identify Descartes' rule of sign. Second, we need to determine the number of positive and negative real zeros for the given function. And lastly, learn its history and how it's used. So now, let's take a moment to learn the history behind Descartes' rule of signs.
The rule of signs was first mentioned in La Géométrie, a book or appendix published in 1637 by the French philosopher and mathematician René Descartes. Now, on to our explanation of how the method or technique works.
So it says here that Descartes' rule of sign is a mathematical tool that helps us determine the number of positive, negative, and complex roots of a polynomial function with real roots. The rule states that the number of positive real roots of a polynomial equation with a real coefficient is equal to the number of sign changes in the coefficient or less than that by an even integer. Similarly, the number of negative real roots of a polynomial equation with real coefficient is equal to the number of sign changes in the coefficient or less than that by an even integer. Let's take a polynomial equation to further understand this rule. So our example is f of x is equal to 2x raised to 5 plus 3x raised to 4 minus 7x cubed minus 2x squared plus 5x minus 1. If the given or example is not in descending order, then we must rearrange it, but as you can see, it is already in descending order. So we have x raised to 5, x raised to 4, x cubed, x squared, and x. Now, we count the number of sign changes in the coefficient. In this case, we have 3 sign changes. This is 1, 2, and then 3. As I said, we have 3 sign changes, which means that the polynomial equation has 3 positive real roots. To find the negative real roots, we need to apply Descartes' rule of signs to the polynomial equation obtained by replacing x with negative x. So now, to find the number of negative real roots, we need to apply Descartes' rule of sign to the polynomial equation obtained by replacing x with negative x. So our equation will look like this. f of negative x is equal to 2 negative x raised to 5 plus 3 negative x raised to 4 minus 7 negative x raised to, or negative x cube minus 2 negative x squared minus 5 negative x minus 1. Now we simplify this. And now after simplifying our given, it has become f of negative x equals negative 2x raised to 5 plus 3x raised to 4 plus 7x cubed minus 2x squared minus 5x minus 1. As you can see, we have two sign changes, 1 and 2. This means that we have two negative real roots. Therefore, based on Descartes' rule of sign, the polynomial equation has either three positive real roots and two negative real roots.
Now let's take a look at some examples. Let us find the number of positive and negative real zeros in the following problems. Let's start with an easy one. f of x is equal to x cubed plus 2x squared minus x plus 3. The coefficients for this one are positive 1, positive 2, negative 1, and positive 3. The sign changes between positive 2, negative 1, and positive 3. This means that there are two positive real zeros. Now, for the negative zeros. f of negative x is equal to negative x cubed plus 2 times negative x squared minus negative x plus 3. Negative x 3 times is negative x. Negative x 2 times means it's positive, so it's positive 2x squared. Negative times negative is positive, so it's positive x. f of negative x is now equal to negative x cubed plus 2x squared plus x plus 3. The coefficients are negative 1, positive 2, positive 1, and positive 3. It changes sign between negative 1 and positive 2. There is one negative real zero.
Hi! So here we have our next example, which is a third degree polynomial, x cubed minus 6x squared minus 7x plus 1. So the first thing we're going to do is find our positive real roots by counting the difference in signs. So our first variable is positive and our second coefficient is negative. So let's count that real quick. Yep. And up next we have our last two parts of the polynomial, which is also in different signs, so that'll count. Now the middle coefficients are similar in sign, so we're just going to ignore that. And here we have two positive real roots. So what about the negative ones? So here's what we're going to do. We're going to convert every variable into a negative one. So negative x cubed minus 6x squared minus 7 x plus 1. Okay, so negative x multiplied into itself 3 times is obviously negative x. Negative x squared is positive. Positive into negative is negative, so that'll be 6x, negative 6x. And negative 7 times negative x is positive 7x plus 1. So the only differences we have here is negative 6x plus 7x. So that'll be one negative real root.
Another example is negative 11x cubed plus 6x squared minus 9x minus 32 equals 0. Our example is set up in descending power of the variable. So our first step would be to rearrange the terms if they weren't in the right order. Now, let's move on to the second step. Second, we count the number of the changes in sign of for the coefficient of f of x. Here are the coefficients of our variable in f of x. Negative 11, positive 6, positive 9, and negative 32. Our variables goes from negative to positive to negative. And now we have to count the changes of sign. Between the first two coefficients, there are changes in sign from negative to positive, so that's 1. And between second and third coefficient, there are no changes in sign. But when we get to the third and fourth coefficients, there are changes from positive to negative, so that's 1. Hence, our number of positive zeros is 2. Now, let's move on to the f of negative x. In order to find the negative 0, we have to find the f of negative x and count the changes of sign for the coefficient. F of negative x is equals to negative 11 of negative x cubed plus 6x of negative x squared minus 9 of negative x and minus 32 equals to negative x cubed plus 6x squared minus 9x minus 32. Here we can see we have two changes of sign, which is from negative to positive to negative 9. Hence, our number of negative zeros is 2. In total, we have 2 positive zeros and 2 negative zeros.
So I will be giving an example of a 4th degree polynomial function. So our given is 2x raised to the power of 4 plus x raised to the power of 3 minus 6x squared minus 7x plus 1. So first, we need to find our coefficient. Our coefficient in this given is positive 2, positive 1, negative 6, negative 7, and positive 1. So the change of sign here is we have 1, 2. So the maximum number of positive real zeros in our given is 2. Let's proceed to find the maximum number of negative real zeros. So we will just substitute the x into negative x. So our given is 2 times negative x raised to the power of 4 plus negative x raised to the power of 3 minus 6 negative x raised to the power of 2 minus 7 negative x plus 1. So our coefficient here is positive 2, negative 1, negative 6, positive 7, and positive 1. So the maximum number of negative real zeros is 2.
So, our example is f close and open parenthesis x is equal to x raised to 6 minus 2x raised to 5 plus 3x raised to 4 minus 10x raised to 3 minus 6x raised to 2 minus 8x minus 8. So, let's start by counting the change of signs. So, my first term is positive and my second term is negative. So, that's a change of sides. Then, it goes from negative to positive. So, there's another change of positive to negative. And the rest are negative. So, there are no more sign changes. So then, there are at most 3 positive roots. Next, to find the possible number of negative roots, we should replace x with negative x and repeat the sign comparison. So, it'll be f close and open parenthesis negative x is equal to negative x raised to 6 minus 2 and negative x raised to 5 plus 3 and negative x raised to 4 minus 10 and negative x raised to 3 minus 6 and negative x raised to 2 minus 8 and negative x. Then, We'll simplify each term so it will be f close and open parenthesis negative x is equal to x raised to 6 plus 2x raised to 5 plus 3x raised to 4 plus 10x raised to 3 minus 6x raised to 2 plus 8x minus 8. So since there are 3 sign changes from the highest order term to the lowest, there are at most 3 negative roots. Now, the possible number of positive roots is 3, and the possible number of negative roots is 3. And on that final note, that concludes our presentation about the Descartes rule of science. I hope you were able to learn a lot from our group. Thank you for listening. Make sure to like, share, and subscribe.